So I need you guys to tune in, grab your coffee, get ready for a ride. Are you ready? Because this is going to be the meat of chemistry. Now that you guys are acclimated to nomenclature, okay? So let's start off with the formula for sodium nitrate. Sodium nitrate, NaNO3. Can you tell me how many sodiums are in sodium nitrate? Diego. Oh, that's right, Mandy.
Wait, so I wasn't unmuted when I said it? Oh, come on.
Mandy and Whitney. Okay, Whitney, since I took Mandy's answer, what about nitrogen? How many nitrogens do we have? We have one nitrogen. And let's see. Aubrey, how many oxygens do I have?
3.
3 oxygens. Okay, pretty simple, right? So by looking at the chemical formula, we can sit there and determine how many of each of the elements that we have, right? And they kind of establish a ratio between each other in terms of that particular compound. Is that cool, understandable, not too hard?
Understandable.
Understandable. Okay, let's see if we can make it a little more challenging. Okay, the question asks, how many atoms of each element are in a formula unit of ammonium carbonate? Ariana.
Yeah.
Ammonium carbonate. Can you give me the chemical formula for that?
I can try.
That's all I can ask of you, right?
Yeah.
Okay.
Would it be NH4?
Okay.
Right? I don't know about the carbonate.
Okay. Anybody want to help her out? Oscar.
CO3. CO3.
CO3. Okay. So is it balanced or is it neutralized or is it zeroed out or is it any of those terms? Oscar, I'll go back to you.
I think I would have first put the charges and then balanced it out.
Okay, so if we have the charges, we'll do this. We'll put it over here so we won't mess up our beautiful formula. What is the charge on ammonium?
It's a plus charge, Dr. Henry.
Okay, and carbonate?
2 minus.
2 minus. Is it balanced?
Nope.
Okay, what do I need to do to balance it?
We would need 2 of the ammoniums. So NH4. Yeah.
Parentheses 2?
Yes, sir.
Okay, perfect. Okay, so we have a nice balanced chemical formula. Now, can you tell me how many nitrogens do I have?
2.
How many hydrogens?
8.
How many, Eileen, how many carbons? You have to unmute yourself, Eileen. Azucena, how many carbons?
1.
Damaris, how many oxygens?
3.
Okay, simple.
Simple.
Yes.
Great. So let's see if we can make it a little more challenging. So now that we have the,
Why though?
what was that?
I'm just like, why though? This is so simple.
You know, this is too easy for you guys. I want to keep you challenged, keep you engaged, right? Okay, so now that we're able to sit there and determine, we can actually name chemical compounds. We can tell me, you guys can tell me how many of each atom or element is in that compound, right? Without any problems, right? You're feeling confident, right? Yeah, I'm getting a couple of thumbs up. Good, good.
Yes.
Okay, so now that you're feeling confident, we're going to continue to build on that confidence. So now we're going to talk about what we call a formula mass and also molecular mass. So if you guys look on your periodic table, what is the atomic mass of nitrogen? You broke up. I think he was saying 14.
Yes.
And we have 2 nitrogens. Is that correct?
Yeah, so that's going to be 28.
Okay. Okay, let's see. Eileen, are you going to answer me or are you going to ignore me? Okay, Erica, tell me about hydrogen. What is the atomic mass for hydrogen?
1,
And how many do we have?
8. That's going to be 8.
Okay. Giselle, what is the atomic mass of carbon?
12.011.
Okay, we're just gonna round up to be simple. We're simple folks.
Okay, 12.
Okay. Okay, Jacqueline, what about oxygen?
16.
And we have 3 of them.
Yes.
3 times 16. 48, right?
Yeah.
Okay.
Yes.
So to get the formula mass for the compound, we have to add all of the atomic masses of the atoms that are there. Okay, so we just add it all together.
$96. I believe so.
Okay,
Yeah.
and then we use AMU for atomic mass units. Sometimes you'll just see units, so you'll see 96 units. And sometimes you will see just mass units. So you'll see all 3, depending on where you're getting it from, but AMU. Now this tells us, in this case, would be the formula mass for this one compound only, okay? So just one of them, okay? Are you with me still?
Yes.
Not too
Yes.
hard. Okay, so let me distinguish. We also have the term molecular mass. Well, so formula mass pertains to ionic compounds, right? Because the way ions actually work, I'm going to show you here in a second, is that you have, let's say, for instance, sodium chloride, NaCl. What do we know about sodium in this compound? What would be the charge on that sodium?
Plus charge.
Positive.
Have a plus charge. So the sodium would have a plus charge, and then the chlorine would have a what?
Negative charge.
Negative charge.
A negative charge. Okay, so when we look at our sodium and we look at our chlorine, we say, oh yeah, there's a sodium and there's a chlorine. It's plus, it's minus, it comes together, everything's perfect. It doesn't quite work like that, even though that's the way I've kind of portrayed it to you. Now I'm going to show you what it really looks like and what it really behaves like, okay? And don't be totally shocked. I know I'm ruining your views and everything, correcting you. Okay, so the black balls are sodium, the green balls are chlorine. So the black balls are the sodium ion, the green balls are the chloride ion. Okay, so sodium is completely positive, right? So that means that sodium sits there, and then a chlorine will come on one side, the other side, the other side, the other side, on top and on bottom, just like this. So if we look in the middle here, we have a chlorine on top, a chlorine on bottom, chlorine here, a chlorine there. So it surrounds it, right? Because it's positive. Those negatives are going to be interacting with it. And then at the same token, the same thing is going to happen to the chlorine by the sodiums. It's going to surround it. This forms a crystal lattice, okay? Do you guys kind of see it, how it works?
Yeah.
Okay.
Yes.
So everything's surrounded by the other atom.
Exactly. Everything is surrounded by the other atom, and it's all based on charge, right? And that kind of makes sense because you guys have played with magnets, and you stick a magnet in there, and you have metals all around it. Don't all the metals come attracting to it, not just one piece of metal?
Yes.
Yeah. Just have my magnet. Where did it go? Okay. So, yeah. So we know that if we had a magnet, oh, here it is, magnet. Magnet. So this piece of metal can attach to it. These other magnets can attach to it. These little guys can attach to it. These little guys can attach to it. So you don't have like a one-to-one type of interaction between the magnet because the magnet puts out an electromagnetic field around it. So the same thing is happening with your ion, is putting around a positive field around it. And then the same thing with the chlorine ion, it's putting around a negative field around it, so that the whole thing is negative. So it's going to be able to attract those positive charges. Okay. So now in this case, we're not getting truly just that single pairing. However, if we go through and we calculated all of the sodiums and we calculated all of the chlorines, it's going to end up averaging out to that same weight. Okay. So basically what I'm saying is that even though I'm making it a little bit harder so that you guys can understand the concept of formula mass versus molecular mass, right? Even though that it is, it looks like this, we make it simple for us to understand, and then also for calculation purposes, right? So we just say sodium chloride. So when we calculate the molar mass of the sodium and the chloride. So what is the mass of sodium? Oh, let's see. Anissa, mass of sodium.
$23.
Jacqueline E, mass of chlorine.
35.
We're going to put that 4-5 because it can make a little bit of a difference. So when we add them together, if I can add 58.45.
Yeah.
AMU. Okay, so we just treat it, when we calculate the formula mass, we treat it just like we're going to do with the molecular mass. But you see the distinction right now. So let me show you what a covalently bonded compound looks like, right? And we call that, when we calculate its mass, we call it molecular mass.
Wait, so what was this one?
So this was in the case of an ionic bond, right? This is called the formula mass.
Formula mass, okay.
Now they're calculated the same way. It's just, as a chemist, we get hung up on those little details. Well, it's not really, truly sharing bonds. So, so we get hung up on details, right, as chemists. And
Okay.
a chemist will ring you over formula mass versus molar mass, but really they're calculated the same way. So there's no distinction in terms of calculations. It's just terminology.
It's just vocabulary, okay.
Yeah. But I don't want y'all guys to say, he didn't talk about that in class. So I'm making sure to talk about it in class. Okay, so we talk about molar mass, molecular mass. We're talking about a covalently bonded compounds. So they're sharing bonds. And so in that case, these guys are physically attached to each other. They're holding on to each other, right? Because they're sharing that bond. So in this case, this is carbon dioxide. The two red are oxygens, the black in the middle, that's carbon. Okay, so when we calculate its formula mass, we take the sum of all of them, right? So how many carbons do I have?
1.
How many oxygens do I have?
2.
2.
Okay, carbon weighs
12 AMUs.
okay. And we only have one of them, so 12. Okay. We have 2 oxygens, and how much does oxygen weigh?
16.
16.
So we add it together,
44.
we get 44 AMU.
Okay.
Okay. So, but do you see the distinction between molecular and formula mass? Excellent. That means yes, because you guys are not answering no, I don't quite get it. Can you go over one more time? Roman, talk to me. Roman ain't shy. He'll tell me the truth.
Kind of.
Kind of. Olga, what about you?
Like if I understand it?
Yeah.
Yeah, it's pretty easy.
Pretty easy. Okay. So pretty easy. So if it's covalently bonded, we call it molecular mass. If it's ionically bonded, we call it formula mass. That's it. The same way of doing it though. You guys get it?
Can you repeat that one more time?
Sure. I'll even put it on the screen. Covalently bonded. It doesn't mean this. I didn't mean to say ass. That did not work out right. Oops. And ionically bonded.
That's formula mass.
Okay. Good. But it's calculated exactly the same way. There's really no distinction in how you calculate it. Okay.
Yes. Thank you, Dr. Henry.
You're welcome. Okay. So calculate the formula mass of ammonium nitrate. Ammonium nitrate. What is the chemical formula for ammonium nitrate? Oh, let's see. Oh, we're going to pick a Roman again. Roman.
NH4.
NH4. And nitrate?
NO3.
Is it balanced?
No, I don't think so.
You don't think so? What is the charge on ammonia? Ammonium, sorry, not ammonia.
Plus,
It's plus. And what is the charge on nitrate?
negative.
Negative? So if I
Yeah,
have one of each, is that going to equal 0?
yeah, so they are balanced.
Okay. Okay, so now let's calculate the formula mass. Let's see. Olga, you're going to help me out with this? How many nitrogens do I have?
2.
How many hydrogens?
4. And oxygen's 3.
Get that proactive. I like it. Okay. Giselle. Tell me, what is the mass of nitrogen?
14.
We have 2 of them. So that's 28. Okay, Jacqueline, what about hydrogen? Jacqueline E.
1.
And we have 4 of them. 4 times 1 is 4. And let's see. I know Mandy. Oxygen. Mass of oxygen. Okay, 16. So Mandy had a question earlier. So she asked, so the atomic mass is the mass of each molecule. No, the atomic mass is the mass of each atom. So molecule meaning that it's together, it's with another atom. Okay, so if I make reference to the atomic mass, I'm talking about the mass of the atom. Okay, so 3 times 16. Okay, 48. Let's see. So we add it together. What do we get?
80.
So it's 80 AMU. Piece of cake?
Yes.
Good. Okay, so I'm going to ask you guys a really, really hard question, and I need you to think really, really hard on this, okay? Promise to do that? Whitney, you promise to do that? Okay, here's my question. Okay, so can you guys see a single molecule with your eyes?
No.
You didn't even give a chance to think about it. You just said no.
Wait, hold on. I'm seeing a lot of single molecules right now.
You're seeing a lot of single molecules right now?
Technically, yeah.
Okay. But can you see a single one by itself, alone? Not if there's a whole bunch of them together.
Just with our eye?
Just with your eye.
No.
No, right?
Yeah.
Like Diego was saying, no, come on, you're being crazy, right? Nobody has eyes that good. Anybody has eyes that
You were
good?
making
Let me
me
know.
doubt
I want to do
myself.
some
That's
things with you. What was that?
You were making me doubt myself. That's mean.
Of course, I got to keep you on your toes, Diego. Okay,
Yeah, it's like,
so
okay, it's common sense, but then I'm being told to think it through. It's like, what do you mean?
it just means think it through. That's all it means. Okay, so if I have a reaction, right, can I take one molecule and another molecule and put them in this nice little thing and see it react?
Also no.
No, I can't, right? Okay, so good. I just wanted to be sure that I understood that, okay? And I wanted to be sure that you guys understood that. So then we have to get it to a form that we can actually understand and makes it a little more tangible to us, right? So we've got to get it to another level, okay? So this brings us to the concept of the mole, okay? Before we get to the mole, I have a couple of questions for you. If I have a dozen of donuts, how many donuts do I have?
A dozen donuts?
A
12.
dozen donuts.
12. Unless it's a baker's dozen.
We're just talking a regular dozen. Don't get fancy on me.
Okay.
Remember, I'm a simple boy. Okay? So a dozen of donuts is 12, right? So we know a dozen is 12. Dozen of anything, right? Is that true?
Yeah.
Okay.
Yes.
So if I had a dozen of husbands, how many husbands do I have?
12.
Well,
If I had a
multiple-
dozen of wives, how many wives do I have?
12.
If I had a dozen of kids, how many kids do I have?
Well,
I like that. Way
Too
too many.
many, according
Okay, so
I'm inclined to agree.
regardless, we know that a dozen is always going to be 12. So if you talk about a dozen, everybody knows what a dozen is, right?
yes.
Right.
Okay, good.
yes.
And let me ask you this. Is a dozen, okay, I just want you to think about it, okay? Again, this is one to think about. So if I had a dozen of grapes and I had a dozen of apples, are they going to weigh the same?
No.
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 Okay. But they're the same amount, right? They're both a
Yes.
dozen,
But they each weigh differently.
but they each weigh differently. Okay. I just want to be sure, making sure I understand things. Okay. So 1 mole is equal to 0.022 times 10 to the 23rd. Which is
You
called,
just said 0.0.
I'm sorry, 6.022 times 10 to the 23rd. Do as I write, not as I say.
Okay.
Okay, 6.022 times 10 to the 23rd. Okay,
This sounds familiar from a high school chemistry class.
excellent. We want to get you
And
to
then
that. Right?
And then I remember some guy with a name who sounds like avocado.
That's right, Avogadro.
That's the guy.
Avogadro's number. Okay, so this is Avogadro's number. 6.022 times 10 to the 23rd. Okay, so Avogadro's number is equal to 1 mole. So 1 mole is equal to 6.022 times 10 to the 23rd. Repeat that after me, please.
6.022 times 10 to the 23rd.
Equals what?
1
One
mole.
more.
Avogadro's number.
Okay,
1 mole equals
1 mole.
2 times 10 to the 23rd.
say it again.
1
All of you, I
mole.
want to hear it.
One
I want
mole
everybody to say it
is-
together. On 3, ready? 1, 2, everybody turn. Unmute yourself, unmute yourself, unmute yourself. I want everybody to say it. 1, 2, 3.
1
mole
mole
equals
equals 6.022 times 10 to the 23rd
power.
Okay, so
Wow,
next
perfect
I want you guys
harmony.
to do is to all get a tattoo of Avogadro's number written on your chest. Okay?
I
Is
do
that
not
cool?
consent.
Well, you can get your parents to sign off on it. Don't worry about it. They'll do it. Okay?
Highly doubtful.
So we want to make sure you remember it, right? We also want you to remember that it's quantity, right? So if I have a mole of girlfriends, How many girlfriends do I have?
6.02
more than
times
there are
10
on
to the
Earth.
23rd.
Okay. So if I have a mole of girlfriends, I'm going to have a mole of problems. How many problems am I going to have?
A mole of them.
How many
Unless
problems?
there's an actual scientific calculation to figure that out.
If I have a mole of problems, then how many problems will I have? Come on, I want to hear it.
6.022 times 10 to the
6.022
23rd power.
10 to the 23 power.
Now, I know you guys are saying, why is he making us say this all the time? Because you guys at some point will forget what a mole means. I promise you by the end of the day, somebody's going to sit there and say, doesn't that mean the mass? Okay, so I want you guys to recognize that it's quantity, right? It's quantity. That's what it is. A mole can be anything. It could be atoms. It could be molecules. It could be underwear. It could be girlfriends. It could be boyfriends. It could be husbands. It could be wives, right? It'd be a whole bunch of wives and a whole bunch of underwear, right? So a mole is going to be very important for what we're going to be doing, and it represents quantity. Okay? Are you with me?
Yes.
Yes.
Okay.
Yes.
Now I can go to the next level. So we can talk about molar mass. Let's see. Okay, molar mass is defined as grams per mole. So carbon is very important to us. Carbon is such a whore, but it's so important, right? Everybody loves a whore, right? So carbon basically helped us define what a mole was. That value there, 6.022 times 10 to the 23rd, that was based upon the carbon atom. So they found when they were weighing carbon, that 12 AMU is also going to equal the same mass for 1 mole. Okay, so it'll be 12 grams per 1 mole for carbon. So the isotope carbon-12 was basically used to define basically the weight for the periodic scale. Okay, so we can say that carbon, 12 grams of carbon is going to be 1 mole, right? 1 mole quantity. So how many atoms of carbon are in 12 grams of carbon?
1 mole.
How many atoms of carbon? I want quantity. 1 mole.
Okay, 6.022 times 10 to the 23rd.
That is correct.
Atoms.
Okay. Do you guys get that, right?
Yes.
Okay. Mandy asked a question. She's like, how do we know when to round and when not to round? So when you're using the numbers from the periodic table, I always, if I have 12.011, right? In this context, I'm going to round to 12. If I have 18.998, that point, I'm going to round to 19. If I have 35.45, I'm not going to round because that 0.45 could actually start making a difference depending on how many you have, right? And if you round, then you're kind of cheating yourself out of a little bit. So if I have a 0 here, I'm going to round. If I have like 8.99, I'm going to round because this is essentially 19, right? But if I have 35.3, I'm not going to round because it can make a difference depending on how many molecules I have or how many atoms I have in that. Does that make sense? But if you take a look at your periodic table, then compare it to somebody else's periodic table, like a different type of periodic table, right? And another different type of periodic table, the numbers are not consistent. They don't go out to the same number of significant figures. So you're never going to use your periodic table to determine your sig figs. You're going to use what you're working with to determine your sig figs. Does that help? Good. Okay, so we can also use the quantities on a periodic table for grams per mole, right? And so then that gives us mass in respect to quantity. Okay, does that make sense?
Can you repeat that again one more time, Dr. Henry?
I said, so we can use the periodic table to sit there and determine our molar mass, right? So for instance, fluorine. What is the molar mass of fluorine? I mean, the atomic mass of fluorine, not molar.
19.
19. So 19 would also be the molar mass of fluorine, right? Because it's 19 grams per mole. Let me write that down, molar mass, so you guys can.
Just trying to be all about the games. Talking about some, teach me how to.
But Dr. Henry, isn't fluorine diatomic?
If we're talking about the element, right, itself. So here we're just talking about the atom. Do you understand?
Yeah.
So if I was asking you about fluorine gas, you know, or the element fluorine, then we know that
I was
fluorine
on
is
the
a
call with
diatomic element.
Sophie.
What was that?
I was all
Keep it
confused.
short.
I
I was on the
heard
call with Sophie. She got back from hanging out with Sebastian. She got here like talking about Sebastian.
Okay, we're talking about Sebastian now. Okay, so the fluorine, so there's a distinction between the atom and the element. The element is diatomic. The atom itself is just itself. So you could have fluorine in a compound. It's not going to be diatomic. It is not going to be diatomic. You guys get that? So you don't want to distinguish like between the two. So if I ask you for the atom fluorine, then you're just going to give me that atom. Do you understand? Does that help, Cole?
Oh yeah, that helps. I know I get that question every semester, so it's just
Yeah, and you will get it again, I promise. So, yeah. But if I ask you for the molecule fluorine, so what am I making reference to? In that case. So in that case, I would be making reference to the gas. So then it would be F2, right? Because the only way that it could be a molecule is if there's two or more, right? Remember those definitions? Guess I need to put something else on the test, huh? Okay. Okay, so you guys are comfortable with about a mole? You understand what it means?
Yes.
Okay, good. And how we can use it for mass and we can use it for quantity, right? Okay, so a sample consisting of 0.25 moles of ammonia. A sample consists of 0.25 moles of ammonia. How many ammonia molecules is this? So where am I going to start? Jacqueline L.
Yeah.
Where are we going to start?
So we're going to do 0.25 moles and set it up so 1 mole equals 6.022 times 10 to the 23rd molecules.
So what is the chemical formula for ammonia?
That's NH3, I think.
Okay, good job. So you said 1 mole at the bottom?
Yes, because we want the units to cancel out.
Okay. And then 6.022 at the top?
Yes.
And that's molecules of ammonia. Okay, so how many sig figs?
We're multiplying, so we would want to keep, is it the least amount, right?
Okay,
So that would be 2.
and we also know that this here is it's a rounded number and technically goes on and on and on and on and on and on and on. So because of that, we're only going to use what's given in terms of our sig figs. So we wouldn't even use these guys, okay?
Okay.
And if it's an exact number, the same thing. It's kind of like saying 0.00000000 in the case of it being exact. Okay, questions, concerns, cash, credit, Rolexes, Porsches? Okay, sounds good. We're moving. You guys are so exciting today.
I just need to learn this because I need to rap about it.
Okay, so we've talked about molar mass, right? And then we talked about it being based upon carbon 12, actually. Okay, so similar to what we did with our formula mass or our molecular mass, molar mass is going to work the same concept. You're just going to take each of the components and you're going to add it up, and then that's going to give you your new molar mass. Okay, so let me give you an example, or actually, let's work on an example together. Calculate the molar mass of calcium fluoride. Let's see. Whitney. Chemical formula for calcium fluoride? That is correct. CaF2. Jacqueline E. How many calciums do I have in calcium fluoride?
One.
Okay. How many fluorines do I have in calcium fluoride?
2.
Okay, so let's see. Erica, what is the molar mass? The atomic mass for calcium?
40.
And we have 1. So what about fluorine?
19.
And we have 2.
38.
So if we add these 2 together, it's going to be 78 grams per mole. Okay, and you guys know what it means when I say grams per mole. You know what that means, right? Yeah, same thing as saying 78 grams over 1 mole. That's what it means. Okay, so that's why we always can sit there and do that. When you get the molar mass, it's always going to be over 1 mole. Okay, simple. Excellent. That means yes. I love it. Today's an easy day. We're going to finish this chapter, and I think we're going to get to chapter 8 and chapter 9 at this rate. Okay, so this slide is an example of, we have 1 mole of all of these elements, and we have 1 mole of all of these compounds. Do they look like they're the same weight? Or are they the same weight? Yes, no, maybe?
No.
No. Obviously, because we have the weight down here, right? 55.85 grams per mole. 26.98 grams per mole. Right? So they're not the same weight. But they're the exact same quantity. This here, guess how many atoms of iron are there? Take a guess. Aubrey, how many atoms of iron are there?
One.
There's only one atom? You can see 1 atom with your eyes?
A lot. I don't know.
I would definitely say a lot. So if it's 55.85 grams per mole, that means you have 1 mole of substance. And we know that 1 mole is equal to how many atoms? That's right, Whitney. It's equal to 6.022 times 10 to the 23rd atoms. Remember, at the beginning of the class, what did I tell you we're going to do?
Repeat it and repeat it.
That's why I want you to repeat it and repeat it, because I said you're going to forget it. Watch, you're going to forget. You're going to forget. Nobody believes me. Okay, so sodium. Sodium weighs 22.99 grams per mole. So how many atoms of sodium are in that glass? Audrey, will coming back to you.
It's 6.022 times 10 to the 23rd.
23rd, that is correct. You need your coffee, right? Your coffee, sneak in. Okay, so that is correct. So when we're talking about 1 mole, we know that we have 6.022 times 10 to the 23rd. It could be, if we're talking about an atom, an element like mercury, we know that we have 6.022 times 10 to the 23rd. If we're talking about a molecule like nitrogen gas, we know that we have 6.022 times 10 to the 23rd, because we know that 1 mole is equal to that many. It's equal to that quantity. Okay? Are we good?
Yes.
Good, good. Okay. So you are carrying out a laboratory reaction that requires 0.0360 moles of barium chloride. How many moles of the compound do you measure out? Okay, so we're going to start with this. Jacqueline E., where are we going to start?
With 0.0360 moles of barium chloride.
Okay. Starting out with 0.0360 moles of barium chloride. Okay, what does barium chloride, what is the chemical formula for barium chloride? Roman.
6.022 times 10 to the 23rd.
That tells me the number of molecules That would be in 1 mole of barium chloride.
Oh, what did you want again?
I'm asking you, what is the chemical formula for barium chloride?
Oh, I don't know.
Yes, you do. Look it up. Barium chloride. Tell me. Barium.
Barium is Ba.
Okay. And it's going to have what charge associated with it?
A positive.
It's going to have a positive. Positive what? 1 or 2?
2.
Okay. Then how many chlorines will I need to balance it out?
2.
2. Okay. And chlorine is?
Cl.
Okay. Okay. So that's the chemical formula for barium chloride. Now, the question is, it asks us how many moles, sorry, not how many moles, how many grams of a compound do we need to measure out? So it wants to know grams. So we're looking for grams. That's what our goal is, right? So do I want quantity? Do I want to know how many molecules of barium chloride we have? Or do I want to know the mass of barium chloride that I need to weigh out? I heard somebody say mass. Okay.
Yes.
Okay, so how would I calculate the mass? So obviously I want something that has grams in it, right?
First, find the molar mass of barium chloride.
So we need to find the molar mass of barium chloride. So barium chloride has 1 barium, 2 chlorides. We know that barium weighs what does barium weigh?
137.33.
137.33. And chlorine weighs
35.45.
35.45. And we have 2 of them. So that's what? 70.9. And if we add that together, so that 28.23. And that's units, grams per mole. Okay, so how am I going to use this?
We can use it as a conversion factor.
Okay, we can use it as a conversion factor. So that means I'm going to put what on the bottom and what on top?
We're going to put 1 mole at the bottom and the grams at the top.
Okay. Okay. What did you guys get? How many sig figs should I have?
3.
3 sig figs. So if I have 7.9628, my answer should be
So then shouldn't it be 7.50?
7.50
Yes.
grams of barium chloride. That is correct. Piece of cake?
Mm.
Okay, so let's make it a little bit harder. Too easy. Okay, so if you're given quantity or units, like box units, we have 50 units of trinkets, right? So that's going to be quantity. So if we want to go from quantity to moles, we're going to use Avogadro's number. That Na means Avogadro's number, okay? Now, if we have moles and we want to go to grams, we're going to use molar mass. MM stands for molar mass, okay? We know that molar mass is in grams per mole. We know that Avogadro's it's moles per or quantity of anything, right? So 6.022 times 10 to the 23rd, right? Simple, not too hard. Excellent.
Yes.
Good. Okay, so this is just basically another flow chart showing you exactly the same thing. So here, if you're given mass in grams, if you have molar mass, you can get moles, right? If you're given moles, you can get quantity, and you can go between all of these, okay? So you got to be flexible. You can't be just one way. You got it? Are we good?
Yes.
Okay,
Yes.
you flexible? Oscar, you're flexible?
Yes, sir.
Excellent.
I pulled a muscle getting out of bed.
So you're not too flexible. Is that what you're saying?
Yes.
Okay, so here's the question.
Physically.
Determine the mass in grams of 3.2 times 10 to the 24th molecules of sulfur tetrafluoride. Okay, where are we going to start?
Find the molar mass of sulfur tetrafluoride.
Okay. So what is, first off, we probably need to figure out what sulfur tetrafluoride looks like chemically, right?
Yes.
What's the chemical formula for sulfur tetrafluoride? That is correct. SF4. Okay. So you said find the molar mass. What is the molar mass of sulfur tetrafluoride? Sulfur, how many sulfurs do we have?
1.
Okay, we know that sulfur weighs
32.
Okay, fluoride, how many do we have?
4.
And fluoride weighs
19.
okay. So 4 times 19, 76 plus 32.
108.
Okay, so what am I going to do with this? So what am I given?
The amount of molecules.
Yeah.
Gram.
So we're given 32.2
Same.
times 10 to the 24th. So you're always going to start with what you're given, right? Of course, after you find the chemical formula, because that's going to be very helpful. So we have molecules. Molecules. What are molecules again? Is that quantity? Is that mass? Is that hotcakes?
It's a thing.
It's quantity.
It's quantity. So what are we going to use to get rid of quantity?
What?
What was that?
That's me thinking. I'm just like, what?
Roman, what do you think we're going to use? We're starting with quantity.
The 108 grams per molecule.
So, but this isn't per molecule. Mole and molecule are not the same, so don't mistake it. 1 mole can equal 6.022 times 10 to the 23rd molecules, but a mole and a molecule are not the same thing. Okay? Do you understand? So, because a mole could also be an atom, a mole could be a shoe, right? It could be making reference to shoes. It's kind of like the same thing as a dozen, right?
Mm-hmm.
So it just represents a quantity. So what am I going to use though? So this tells me that this is 108 grams per 1 mole, right?
Mm-hmm.
So that's mass per mole. Right now I have molecules. How do I get molecules to moles so that I can use that?
6.22 times 10 to the 23rd.
That is correct. I need to use Avogadro's number, 6.022 times 10 to the 23rd. And that I could say molecules in this case. Of SF4. And we know that's equal to 1 mole. Of SF4. So we've gotten rid of molecules, and now we have moles of SF4. So how do I get to mass?
Plug in the rest.
Okay, I plug in the rest.
The 108.
Is that on top or on the bottom?
On top.
Over 1 mole. So then moles are going to cancel out, and we're going to be left with just grams. Exactly what we wanted. How many sig figs?
Two.
Okay. So my answer is, on my calculator, is 573.896 grams of SF. So my final answer would be, taking in consideration sig figs, is that I have 2 sig figs. So then what would my answer be? Jacqueline E., what would be my answer?
57.
57? If I have 573?
573.896.
90?
If I have 2 sig figs,
What?
Would it be 500? Oh, wait, never mind.
I'm confused now.
okay, so the
0.7.
Oh!
the answer should be 570. 2 significant figures, right? 1, 2. That 0 is insignificant. Remember, we need to use those zeros for space holders. So don't forget everything that you learned in the beginning. Don't throw that stuff out the window. You're still going to need it. Okay?
Okay.
Okay? Be ready because I'm gonna be looking for it. Not this exam, you guys kind of got off on it because we didn't do too many. There'll be a few, but there's not too many mathematical equations going on there. But the next one is all math. So you want to be on point with your sig fig. So look over your notes, make sure you understand it. And you know that 57 isn't the same thing as 570, right? So if I gave you $57 and you were expecting $570, you'd be pissed off, wouldn't you?
Yeah.
Yeah. So don't forget the placeholders. The 0 serves as placeholder. Okay. Next, let's go. And you guys need coffee. If y'all don't come next week with coffee, I'm
Would
going to
it
be
have
upset.
still been correct if it was like 5.7 times 10 to the second?
That would have been correct
Okay.
as well. Yep. Scientific notation is always acceptable. Okay. Percent composition by mass. So percent composition by mass is pretty simple, right? All you're going to be looking at is the part over the whole. Now, what do I mean by that? So earlier we calculated calcium fluoride, the molar mass, right? Calcium fluoride, we know that it's CaF2. So that means we have 1 calcium and 2 fluorines, right? Or 2 fluorides. So we know that calcium weighs 40, is that right? And our fluorine weighed 19. There's 2 of them. So altogether, we had a molar mass of 78 grams per mole. Is that true? Or am I just making stuff up?
Yes, that's true.
Okay, so if I'm taking the part over the whole, if we're looking at fluorine, what is the mass of the fluorine in this compound? How many fluorines do I have?
2.
I have 2. 2 times 19 is what?
It's 38.
38. So 38 over 78. Times 100. And then that's going to give us our percent mass for fluorine, or the fluoride in the compound. Okay, so what do you guys get?
$48 point something 70. Oh, okay.
Piece of cake? So Mandy, you're lost. Let me see if I can find you. So calcium fluoride is made up of what? Anybody can answer. It's made up of calcium and fluoride, right? We know when we balance the equation, calcium, we have 1 calcium, we have 2 fluorides, right? Make sense? You're good there? Okay, so we know that calcium weighs 40 grams per mole. And we know that the fluorides, each one weighs 19 grams per mole. Are we good there? Okay. So now our total mass is 78. So it's part. The part represents whatever element that we're looking at or whatever atom we're looking at. So in this case, we're looking at fluorine, right? So we put the amount, the mass of the fluorine, because it's percent composition by mass. So the mass of the fluorine over the mass of the total. Okay. Is that good? Everybody's good?
Dr. Henry, would you do it for the calcium as well, or just?
So you could do it for the calcium as well, or you could just subtract it from 100, right?
Oh.
And this would be for fluorine. So if we went 100, because we know if you have 100% of something and 48% of it is one thing, the other has to be the other thing, right?
Yeah, for sure.
Okay. Or you could actually do the same thing. You just put the 40 divided by the 78.
78.
And it should give you the same answer. Right? What is that? 51.3%.
Yep.
Piece of cake, not too hard.
No.
Okay, good. Let's see if we can make it harder. Okay. Calculate the percent composition by mass of aluminum sulfate. So what am I going to do? Nisi. Oh, she's at that. Let's see. Jacqueline L.
Yeah.
So what am I going to do?
We have to write our formula first.
Okay.
Which would be, trying to find it. It would be Al2SO4 3. Correct me if I'm wrong, anybody.
Is it like this 3 or is it SO4 3?
It's like you have to have it in parentheses.
Okay. Anybody disagree? Anybody agree?
That looks right.
Yes.
It's right? Okay. So you got agreement.
Okay, good.
Okay.
So
Right.
we're going to calculate the mass.
Okay.
We have aluminum, there's 2 of those.
So you're the mass or the molar mass?
We're trying to find the molar mass of
Okay.
the compound.
Okay, so 2 Al.
Yes. That would
And
be
Al weighs how much?
27.
Okay.
And then 54. So then sulfur, we have 3 of those. And that weighs 32.
Okay.
Okay, then we have oxygen. We have 12 of those. And that weighs 16. Okay, so 16 times 12 is 192. So once we add all these up, we get 342. Okay, so now we have to find the percentage composition by mass of aluminum sulfate. Percentage composition.
So we want to do each one. So aluminum.
Oh, okay, okay. I was looking for one specific one, but so we have to figure out for all of them?
Yep.
Oh, okay. I see. All right, so we would just set that up by doing the part over total.
Okay.
So for aluminum, it would be 54 divided by 342. And we're going to multiply that by 100, which gives us 15.7, or I guess 15.8%.
Okay.
And then for sulfur, we would do 96 divided by 342. Multiply that by 100, which gives us 28.1%. And then for oxygen, we would do 192 divided by 342, multiply that by 100 as well. We get 56.1%.
Okay. Piece of cake. Okay.
Okay.
Yes. So Mandy, not Maddie. Mandy asked for your short answers like this, do I want the units at the end of it? You always want to put your units because you could be talking about pies, I don't know. Okay. So you want to say grams of whatever it is you're talking about, because I'm not a mind reader. Yeah, so you could write it as in grams in your calculations as well. So if you, but mainly make sure you have the correct units at the end. And it's actually should be grams per mole because you're talking about molarity. I mean the molar mass. Okay. Questions, concerns, Cash? Good. Okay. Let's see. Let's see. Oscar. No, actually, Azucena. I was going to have you do the next one. Here we go. Azucena, aluminum chlorate is 38.35% chloride. What mass of aluminum chlorate is needed as a source of 50.0 milligrams of chloride?
We do first our chemical formula.
Okay. So what is our chemical formula?
It'll be Al2.
Are you sure Al2? What is chlorate?
Chloride is ClO3 with the negative charge.
Do
they balance out? No, aluminum has a +3 charge, so you would need 3 of the chlorates.
Okay, so it would be Al ClO3 in parentheses, and you said 3. Okay.
Yes.
Do you agree with that, Azucena? I think we lost her. Yeah. Okay. So who's going to help me out with this now? So we got the chemical formula. So what are we going to do next? Anyone?
Find the what is it? The molecular mass or what?
So we could find the molecular mass, but do we really need it? Because there's something that's given to us here that makes it so much easier to figure things out. What is the definition of percent mass? So if we're talking about chlorine over, if we're talking about the percent mass chlorine, what would be the definition of that? How would we calculate that? Give me an equation to calculate that. Oscar.
What was the question again, Dr. Henry?
I said, what is the definition of percent mass? So if I'm asking you for percent mass of the chlorine, how would I calculate that? What is the definition of percent mass? Anyone?
You would need the amount of chlorine divided by the total amount of the whole
So the mass, of chlorine, or the chloride, and you said divided by the mass of the whole compound, the mass of the aluminum chlorate. Okay, times 100, right?
Yes.
That's the definition. Is that right? Right or wrong?
I'm sorry, my bad. My internet is going a little bit down.
That's all right. Don't worry about it. Your colleagues, your classmates helped you out. They were picking up the slack. So, and we know this is going to be equal to what?
38.35.
38.35%. Okay, so I'm over time. So we're going to stop here.